Hello everyone, this is Zulekat Faima of CSA Cybersecurity Department, pursuing my education in Sri Venkateswara College of Engineering, Bangalore. I am here to talk about the topic Poisson distribution in mathematics. So let's see about the introduction to Poisson distribution. The Poisson distribution is a discrete probability distribution that models the number of events occurring in a fixed interval of time or space. It is named after the French mathematician Simon Denis Poisson, who first introduced the distribution in the early 19th century. The Poisson distribution is widely used in various fields, including biology, telecommunications, finance, and queuing theory. Let's see about the key characteristics of Poisson distribution. Poisson distribution is defined by single parameter lambda, the average rate of events occurring in a given interval. The probability mass function of Poisson distribution is given by P of x lambda is equal to e to the power e square minus lambda, where x is number of events and e is Euler's number. Application areas of Poisson distribution. In biology, the Poisson distribution is used to model the number of mutations occurring in a DNA sequence. In telecommunications, it is used to model the number of phone calls arriving at a call center within a specific time period. In finance, the Poisson distribution is used to model the number of trades executed in given time interval. Poisson distribution versus binomial distribution. The Poisson distribution is often used as approximation to binomial distribution when number of trial is large and success probability is small. The binomial distribution models the number of successes in a fixed number of independent Bernoulli trials, while Poisson distribution models the number of events in fixed interval. As number of trials in binomial distribution approaches infinity and success probability approaches zero, the distribution becomes Poisson. Poisson distribution example, that is radioactive decay. The decay of radioactive isotopes is a classical example of Poisson process. The number of decays occurring in a given time interval follows a Poisson distribution. The average rate of decay, lambda, is related to half-life of the isotope. Properties of Poisson distribution. The Poisson distribution is a memoryless, which means the probability of an event occurring in a given interval is independent of number of events that have already occurred. The sum of independent Poisson random variable with parameter lambda 1 and lambda 2 is also a Poisson random variable with parameter lambda 1 plus lambda 2. The Poisson distribution is symmetric if lambda is an integer but becomes increasingly skewed as lambda increases. Poisson distribution assumption and limitations. The Poisson distribution assumes that the event occur independently and at a constant average rate. It may not be suitable for modeling events with varying rates or events that are dependent on each other. The Poisson distribution is only valid for non-negative integer value of x. In queuing theory, the Poisson distribution is used to model the arrival of customers or tasks. It helps in analyzing the waiting time, queue length, and system utilization in queuing system. The Poisson distribution is often combined with other distributions, such as exponential distribution, to model service times. Queuing theory is the study of waiting in lines or queues. Estimating parameter of Poisson distribution. The parameter lambda of Poisson distribution can be estimated from sample data using maximum likelihood estimation. The sample mean is unbiased estimator of lambda. Confidence intervals can be constructed to estimate the uncertainty associated with estimated parameter. Relationship between Poisson and normal distribution. When the average rate lambda is large, the Poisson distribution can be approximated by normal distribution. This approximation is also known as Poisson approximation to normal distribution. As lambda increases, the Poisson distribution becomes more symmetric and bell-shaped like normal distribution. Poisson distribution in risk analysis. The Poisson distribution is used in risk analysis to model the occurrence of rare events such as accidents or failures. It helps in assessing the probability of these events happening within a specific time frame. By analyzing the Poisson distribution, risk management strategies can be developed to mitigate potential losses. Poisson distribution in sports analytics. In sports analytics, the Poisson distribution is often used to model the number of goals, points, or runs scored by a team in a game. It helps in predicting match outcomes and evaluating team performance. By analyzing historical data, teams can make strategic decisions based on expected number of goals or points. Limitations of Poisson distribution. The Poisson distribution assumes that the event occur independently and at a constant rate, which may not always be the case in real world scenarios. It may not accurately model events with long tailed or heavy tailed distribution. Extreme values are less likely to occur in the Poisson distribution compared to other distribution. Poisson distribution in quality control. The Poisson distribution is used in quality control to model the number of defects or errors in production process. It helps in accessing the quality performance of a product or a process. By monitoring the number of defects, or organization can identify areas improvement and take corrective actions. Application of Poisson distribution in epidemiology. In epidemiology, the Poisson distribution is used to model the occurrence of disease outbreaks or number of cases within the population. It helps in studying spread and impact of diseases and evaluating the effectiveness of inventions. By analyzing the Poisson distribution, public health officials can make information decision about disease prevention and control measures. Poisson measures distribution in traffic engineering. The Poisson distribution is used in traffic engineering to model the arrival rate of vehicles at intersections or on highways. It helps in analyzing traffic flow, congestions, and capacity planning. By understanding the characteristics of traffic using Poisson distribution, transportation planners can design efficient road networks. Using Poisson distribution in project management. The Poisson distribution is used in project management to model the occurrence of events such as delays or equipment failures, in estimating project timelines, resource allocation, and risk assessment. By analyzing the Poisson distribution, project manager can identify critical events and allocate resource accordingly. Poisson distribution in inventory management. The Poisson distribution is used in inventory management to model the demand rate for products of arrival rate of customer orders. It helps in determining optimal inventory levels, reorder points, and safety stocks. By analyzing the Poisson distribution, organization can minimize stockouts and reduce carrying costs. Summary of Poisson distribution. The Poisson distribution is power for modeling the number of events occurring in fixed interval. It has various applications in fields such as biology, telecommunications, finance, and queuing theory. The Poisson distribution is characterized by single parameter lambda, which represent average rate of events. The Poisson distribution provide a valuable framework for understanding and analyzing random event. Its simplicity and flexibility makes it widely used distribution in many fields. By applying the principles and properties of the Poisson distribution, researchers and practitioners can make informed decisions and solve complex problems. By here, I end up my topic. Thank you.